Ladies and gentlemen, welcome to section 8.8, Differences of Squares, part 2. With number 1, we are asked to factor this polynomial, and remember, when we factor polynomials, what's the very first thing that we have to do? Well, is there a number or letters that we can take out of everything? Well, I look at it, I see that there's a 7 in everything, so I'm going to take out that 7. The letters, no letters that are the same, so then I rewrite this, h to the 4th minus p to the 4th. Now we go ahead and bring this 7 down, and now can I rewrite this at all? What multiplies times itself to get h to the 4th? Well, hopefully we said, after I make the parentheses, hopefully we said that it's h squared, because h squared times h squared will give us h to the 4th. What will give you p to the 4th? What times itself will give you p to the self? Well, it will be p squared and p squared. Now with this plus in between two squares we can't touch, but how about this minus? Is there anything that multiplies to an h squared times itself? So I get to actually break this down one more time. I'm going to go h minus p and then h plus p, because h times h is h squared, a negative p times a positive p gives me p squared, and now let's bring down everything else that we didn't use. I didn't use that 7, and I didn't break apart that, so I'm going to bring that down over here, so it's h squared plus p squared. And now this is your factored form of number 1. This is your answer for number 1. Let's try number 2. Now sometimes they won't have numbers in there, they'll just have letters. Can we take out any of the letters? Well, here I have a p cubed, and here I have a p cubed, so I'm going to take that out and put it out front. Well, how about r's? Here I have an r to the 5th, here I have just an r, so I'm going to take out that r and put it right there. Now what's left? I have no p's left from here, but I have an r to the 4th left. I have no p's and I have no r's left, so I just have minus 1. Now, a little bit tricky here because it's r to the 4th minus 1. What times itself will give you r to the 4th? Well, hopefully after doing enough of these problems, we realize that it's r squared minus 1 and r squared plus 1. Bring down everything else that we did not use, which was the p cubed r. And now hopefully that we realize we're going to have a lot of these problems today that we're not going to be done after the first step or the second step we factor. We have to keep looking at our factors and seeing if we can factor it anymore. Well, just like this guy in the middle, can we factor this guy anymore? Well, what multiplies times itself to r squared? That is r, and then it's going to be plus 1 and minus 1, and then go ahead and bring down everything else that we didn't use. We have a p to the 3rd times r, and then we have r squared plus 1, r squared plus 1. And so this guy will be your final answer. Now number 3 throws a couple more terms at us, but we just have to follow the rules of factoring. First rule is there anything that we can take out of all those 4 terms? Yes, there is. We can take out that 6, so then we'll be left with an x cubed plus a 5x squared minus a 4x and then minus 20. And I close that up. Now we have to remember back a couple sections ago, what do we have to do when there's 4 terms? What we have to do is we have to group this stuff, and I'm going to group it here and here, and now I'm also going to group it with that minus sign included, and I'm going to throw a plus right smack dab in the middle of those parentheses. So now when I factor this, I'm going to factor this guy and factor this guy and throw some things together. Well, what can I take out of here? I can take out a x squared. What will be left inside my parentheses? Well, I'll have a x plus 5 still left in my parentheses. Now, how about here? What can I factor out? What's a common term I can factor out? What about a negative 4? Because 4 goes in here and 4 goes in there. So I'm going to factor out that negative 4, and I'm going to be left with x plus 5 and close that up. Now we have to make sure that we include everything that we did not use, so I have to bring down this 6. Now when we factor it again, Notice how we have this like term and this like term. So let's bring that out. So we have 6 now times, and now I'm going to write these two guys here, which is x plus 5. And now I bring down x squared minus 4. One more time. Can I factor anything in? Can I multiply? Is there something I can multiply times itself to get x squared and something times itself to get 4? Yes, and that is x and x to get x squared, and then a minus 2 and a plus 2 to get 4. Now we have to bring down everything else that we didn't use, so let's bring down that x plus 5, and then also that 6. Now we also have to include some parentheses, and now here is our final answer. This is the answer that we're looking for in number 3. Let's try another one. 4. Remember, what's our first rule of factoring? Is there anything that we can take out of every single term? There is not. So let's start to group it. Let's group the big variables with the big variables, the small variables with the small variables, and I'm going to throw a plus sign right between my parentheses. What can I factor out of here? Well, I can factor out a m squared. I will be left with a 2m plus 1. How about here? What can I factor out? I can factor out a negative, because they are both negative, so I highly recommend that you factor out a negative 25 to make life easy for yourself. You will be left with a 2m plus 1. Well, I'll do our factors. Do we have the like terms, like factors? Yes, there and there. So that turns into 2m plus 1. And now what do we have left? We have times m squared from right here, and then minus 25. Now, can we keep going with this? Yes, we can. We can go m, because m times m gives us m squared, and then what times itself gives you 25? How about minus 5 and plus 5, and then bring down what you didn't use, which is 2m plus 1, put it in parentheses, and we found what we were looking for, and there is the whole thing is our answer to number 4. And now let's try one more problem. Hang in there. Now it's a word problem, everybody's favorite. Well, very first thing we have to do is read it. You might not understand it the first time. Well, let's read it again and see if we can get any more information out of it. So here we go. The sales of a particular CD can be modeled by the equation. Well, since it says the equation, I'm going to guess that this is a big hint for us, where S is the number of CDs sold in thousands, and M is the number of months, and M is the number of months it is on the market. Well, we are asked for, in what month should the music store expect the CD to stop selling? To stop selling. Well, if you were a business owner, when would you stop selling the CD? Well, I think I would stop selling it when I know it would be at 0, when I could sell no more copies. So, where would I put 0? Would I put 0 in for the months, or would I put in for the number of CDs? Hopefully, we said the number of CDs, so I'm going to put 0 right in for this S. So it's going to be 0 equals a negative 25m squared plus 125m. Now, we just have to factor with it being equal to 0. This equal to 0 does not change anything for us. What can we take out? Let's try and take out that negative 25m. So now we'll be left with a m minus 5, because I took out that negative, so it makes this a negative. Now, let's set both of them equal to 0. Here we have, and I'm going to go over here, negative 25m equals 0, and we have m minus 5 equals 0. Well, if I divide by negative 25, m is still 0, but here if I add over the 5, m equals 5. So which one makes more sense, the m equals 0 or the m equals 5? M equals 0 is just like we're starting, so that doesn't make too much sense. How about m equals 5? This means that, and since m equals 5, that we should stop selling it after 5 months. Now, part B. How many copies will the CD sell at the sales peak if the sales peak is at 2.5 months? Well, what does this 2.5 months mean to me? Well, it says 2.5 months being the key word. Well, what's the number of months in the problem? It's your M. So I'm going to guess that we're going to plug 2.5 in for our M's. So let's go ahead and do that. We have S equals a negative 25, and then I'm going to change my color and plug 2.5 right in for that M, squared from your problem, plus 125, and then times 2.5. Let's go right down the list here, or right down the row. So I'm going to square this first, right? Square this first, and then multiply it times the negative 25 to get negative 156.25, and then you multiply this out to get plus 312.5. And now, again, plug this into your calculator, and you come up with 156.25. Now this is your sales right here. But what is sales, right? This is in thousands, right? This is 156.25 thousand. Now, if you wanted to change it to the real number, you would have to multiply it times 1,000. Now, don't panic, because multiplying by 1,000, how many times do we have to move the decimal? We only have to move it 1, 2, 3 times. So now our true number is 156,250. And so that is 156,250 CDs, or copies of the CD. And that does it for section 8.8, Differences of Squares, part 2. Good day.